Hello students, welcome to my channel. Today I am going to discuss about features of Java. In the previous class we have discussed about the introduction of Java. So here the main features are simple, secured, portable, distributed, multi-threaded, dynamic, high performance, object oriented, robust, platform independent, architectural neutral, interpreted. So these are the important features of Java. So let's see one by one. The first one is simple. So Java is very simple. Why? Because its syntax is quite simple, clean and easy to understand when compared with C and C++, and it is more secure. So let's discuss one by one. The first one is rich standard libraries. So here library is nothing but which is a collection of variables and function. So in normally C and C++, we need to, if you want to perform a specific task, we need to declare functions so that the function can perform a specific task. Okay. So most of the times C and C++ contains many user defined functions. But here in Java, it contains standard libraries. So here libraries contain collection of functions. So if you want to access the functions, we can directly access through libraries. Here some of the libraries are java.io, java.util. So there are many libraries are there. We will discuss in the next classes. For example, if you want to perform any mathematical operations, so we need to import java.lang package. But by default, these are inside the math class. Okay, so that we can perform the mathematical operations without importing any package. So that is the main advantage of Java. Here it contains classes. Classes are nothing but collection of variables and functions. Through classes we can access any variables or functions when we require. The next one is WORA and dry Ora. Ora is nothing but write once, run anywhere. Unlike C and C++, so in C and C++, if you write one program in one system, you can execute that program in that system only. But here, if we write a Java program, once you compile it, so whatever we write, that is known as a source program. So when we compiled it, it will generate the bytecode. So that bytecode can be run anywhere and any system. So here that is the best flexibility of Java. Here write their code once and have flexibility to run various devices and operating system without any modification. And the next one is dry. Dry is nothing but don't repeat yourself. It is a software development principle that encourages developers to avoid duplicate code within a project. Yes. So the dry principle is aimed at reducing redundancy in code, making it more maintainable, readable, and less prone to errors. So it is used to reduce the error prone situations. It provides high security. So Java provides virus free and tamper-free systems. Unlike C++, C++ does not have any built-in runtime security checks, but Java incorporates runtime checks for array bounds, null pointer, and other potential security issues. It helps catch errors during program execution. So that's why it is more secure. So we already discussed about the platform independent. So here platform independent is nothing but we are writing Java program at one time, but we can execute in any operating system. So once the compilation of Java program is done, it will generate bytecode. So that bytecode is platform independent and that can be run on any machine and any operating system. So let's see the example. Here, whatever we write that is known as Java source code. So we save the Java source code program by using extension .java. Whenever we compile the Java program, it will generate one .class file that is known as bytecode. So that bytecode can be run in any operating system. So JVM for Windows, JVM for Linux, JVM for Mac. So you can run on any system. So after executing, it will generate the executable code. So for Windows, the executable code, that means the output will be presented .exe, here .out, and here .dmg. So this is the extension for output. Okay, extension of .exe file for Windows, .out for Linux, and .dmg file for Mac. So this is the process of platform independent. Next one is compiled and interpreted. So C is known as compiled programming language, but Java is compiled and interpreted programming language. So I already said that Java is a high level programming language, but our computers can understand only low level programming language. So here that's why compiler and interpreters are used for translation. Compiler is used to translate from source code to bytecode, and interpreter is used to translate from bytecode to machine code. So that means low level language code that is understandable by the machine. So here the original source code is translated to bytecode, that is the job of compiler, and the bytecode is translated to machine code, that is the job of interpreter. Let's see here Java source code. It contains the extension .java file. The compiler is used to translate from source code to bytecode. So whenever you compile Java program, it will generate one .class file. If the compilation is successful, it will generate .class file, and the .class file is translated to machine code by using JVM, Java Virtual Machine, that is interpreter. Okay, yes. Some of the features are simple is completed, secure, portable. Portable means we can carry from one system to another system. Distribute is also same. Next one is multi-threaded. Multi-threaded is nothing but by using one program. In a one program, we can perform multiple tasks by using multi-threaded feature. And Java is a dynamic programming language. So it means it supports the dynamic loading of classes. It means classes are loaded on demand. It also supports functions from its native language, that is C and C++. Whatever the functions in C and C++, those are also supported in Java. And also next one is high performance. So we can say Java is well performed because of JIT, just in time compiler. So I will discuss it later. Next one is object oriented. Object oriented is nothing but everything in Java is known as one object. Object is nothing but collection of data and methods. Robust. Robust is nothing but it eliminates error prone situations. So we have already seen that Java is translated by using compiler and interpreter. So compiler is used to translate from source code to bytecode, and interpreter is translated from bytecode to machine code. So here we are checking errors at two times, at the compile time error checking and runtime error checking. So that's why Java is robust, platform independent, architectural neutral, and interpreted. So all are discussed. If you have any doubts regarding to this video, please comment me in the comment section. And if you have any doubts, please comment me in the comment section. For more videos, please do subscribe my channel. Thank you.